Thanks, everybody. So my name is Herman. I'm part of the Solutions Architecture team at AWS. I'm actually based in Melbourne, which is significant because of the customer that's going to be talking to you this morning. So as a citizen and as a Victorian, I very much respect the work that our speaker has done over the last few years. You may remember in 2009, Victoria had terrible bushfires. Those bushfires actually had unprecedented loss of life, and as a result, there was a royal commission into those, into the fires and to the emergency services response to those fires. The Royal Commission made a long list of recommendations, but part of the recommendations were that actually a new agency be formed, and so that an agency be formed that would coordinate across the various emergency services in Victoria. So that, fire, police, ambulance, the Country Fire Association, that they would have a coordinated response and have a platform for coordinated response to emergencies. And the other part that was really significant was that the notification systems for the public for emergencies were not adequate. And so a large number of lives had been lost. It was a really tragic event, but so out of that was born Emergency Management Victoria. Michael, the speaker in this session, he's the Chief Architect at Emergency Management Victoria, and I've been in charge of a lot of business critical IT systems in my life, but he has a job that I do not envy. Because the systems that I've been in charge of have been ones where, if it goes down, people are going to lose a lot of money, or there's going to be a lot of unhappy customers. These are systems that, for most of the year, actually lie idle. So IT systems that, for much of the year, really don't have anything to do because there's no emergency on. Everybody's just waiting for the next thing to happen. But then when that emergency happens, if you have, say, a statewide emergency in Victoria, then 2 million people need to be notified within 2 minutes that something's happening. And you need to do that at the same time as you've got a crisis on your hands. You've also got disasters happening that may well be affecting your infrastructure. So you've got fire, flood, some kind of attack, whatever it is. And so you've got IT systems that have to be available to save lives. And they have to be available both to notify the public and also internally to allow emergency services to coordinate. So Michael has been the Chief Architect there for some years and has been through the journey of starting with some IT systems that were essentially designed for on-prem, taking those to cloud and getting them some benefit, and then gradually architecting and re-architecting those into really robust, native, highly available applications. So I'm very happy that Michael's agreed to present for us today, and please help me welcome him to the stage.
Thank you very much, Herman. That was a wonderful introduction. Thank you very much for coming this morning to hear me talk about the journey that we've been on. Now, as Herman mentioned, I am Head of Architecture at Emergency Management Victoria. We're not a big organisation. We're actually a coordinating organisation. So the role of Emergency Management Victoria is to step in when there is a major emergency going on, something beyond the business as usual of the emergency services organisations, and help to coordinate them in response to that emergency, but also to take a leading role in being the face of the emergency response to Victorians and to our visitors. So a big part of that is the public information that we deliver to community members and visitors who might be affected by those emergencies during the course of that event. Other parts of our mandate obviously are to help the communities to prepare for and respond to, and then to recover from these sorts of emergencies that happen on such a frequent basis, unfortunately. So today I'll be talking a little bit about the journey that we've gone through for one particular application, one product that we operate and deliver on behalf of Victoria, and that's the Vic Emergency application and mobile app. I could have picked a few different things, but this is, I think, an interesting topic because it talks to a technology journey rather than the feature or the product journey. A technology journey that many of you in this room have been on or are going through. Now, lots of the talks today will be about one specific technology or domain, whether it's big data or machine learning or something in that frame. A lot of the talks today will be about shifting from data center to cloud and big picture, how you move everything across. I'm just really trying to hit the marks about how an application evolves in a cloud model. So when we're talking about emergencies, Herman hit it on the head. We have fires, major bushfires. We also have floods. We have blue-green algal outbreaks. We have earthquakes, storm events, all sorts of different things that can happen. But when they happen, they're very sudden and they're generally fairly short. So one of the big challenges that we have in emergency systems is responding very quickly to sudden spikes in demand without having a very high baseload cost of running that infrastructure. There's no point saying, well, we're seeing a steady growth in our usage, so we better buy another 30 servers to install over the next 6 months. We have 30 minutes or 30 seconds potentially between having nothing happening and having a very high demand for our services. And in the public awareness and public safety space, that means a significant portion of the population of Victoria jumping on your website or into your app all at the same time, and we get these sudden spikes. But just as importantly, once the information is out there and the emergency response has been well and truly enacted, the public settle and they reduce their demand for information from this channel, maybe from other channels. Maybe they'll watch the news on the nightly news and they'll get their information through other sources and that demand will drop away again. And when it drops away, well, we don't want to be paying for all of those servers anymore. So dealing with that sudden and unpredictable load is as much about managing your limited funds and limited costs as it is in providing an exceptional service during the time of need. So this is sort of a snapshot of the application that was at a point in time. It's Vic Emergency. It's designed to give you that information about everything that's happening across the state. And in its current incarnation, it delivers information on all of the different hazards that which we are aware of. So whether there's potentially earthquakes or floods or storms or fires or tsunamis for that matter, we've got it covered, right? We've got a way of presenting that information to the public, and we've got a single place to do so. So that's great, and we've got a companion mobile app and for iOS and Android, and they're all what they are, what they should be. But we didn't get here overnight. Now, Herman mentioned that we were formed from the Bushfire Royal Commission coming out of 2009 and some Flood Commission. And that was really the impetus to change the way Victoria's emergency services respond to a number of challenges, one of which was public information. So when Emergency Management Victoria was formed, which would have been about 2014, I'll have to check that date, but that had been after the Fire Services Commissioner had been established. And part of the Fire Services Commissioner's role at the time, predating Emergency Management Victoria, was to bring all of the different channels out there at the time, like the fire channels from the Country Fire Authority and the storm channel from the State Emergency Service, and bring them into one location that could be communicated effectively to the public. And so we started that journey from those traditional applications, which were very much on-prem, private data center applications, end-tier, very traditional, probably many of them were J2E applications with their own containers and all that sort of thing, and start to bring them into a more of a modern era. So we were looking at two parts of the problem space at that time, which was how to get everybody to one place, but also how to do so in a way in which we can give them more cost-effective and more performant infrastructure to run it on. Now, at the same time, there was some legacy mobile applications. FireReady in its previous incarnation was in use at the time, and that was very similar. Again, on-prem legacy application, even though it was mobile, and it needed to, again, to be evolved. And so what I've pictured here is just the path that we took as we went from these traditional on-prem applications and took them first to elastic, which meaning, in this sense, cloud-hosted and scalable infrastructure, up to serverless, where we started to remove the management burden of running those applications from a management of this OS level, until where we are today, where everything's running quite smoothly, serverless, but we're starting to look at the future where we start to pare back the number of moving parts even in those applications and to take it to what I'm calling a composed service module. So that journey, as I mentioned, we started from these legacy applications from the agencies that were pretty typically something like this. So N-tier, J2E type applications in containers with a database running on servers with a load balancer and a firewall and all of those bits and pieces that we don't care about anymore because we've all gone serverless, yay. But back in those days, we had all of these problems. Just the care and feeding of an architecture like this took up, sysops, remember those guys? Took up a lot of their time just to keep things running. Database management, changes to firewall configuration rules, getting lots of stuff was painful. And as you can imagine, you had to purchase the infrastructure to support the demand as they saw it. And so when you got that unicorn event, when you got that sudden event as we did in 2009, when the demand absolutely spiked off the charts, what could they do? They could do nothing. The systems fail. Theoretically, I don't know specifically about this particular application, but in those sort of scenarios, you can't trust that your application is going to meet that demand unless you've tested it to that level ahead of time. And to test it to that level ahead of time, you better have spent all of that money on the infrastructure and then kept it up to date, right? And in government, who's got the money to do that, right? So that was challenging. So when we talked about taking these applications and bringing them together on a new platform, the first thing we were looking for was resilience. So whatever platform we were to put in would have to be a resilient platform, minimize the points of failure, trying to offload some of the more common load events into the environment. CloudFront in this case was an obvious choice. And try and add to the resiliency through the use of availability zones. So try and get that same multi-data center resiliency, but to do so in a way that gave us the cost advantages of the platform without the expense required to build up the data centers. Obviously, designing for capacity was a core driver, so making sure that what we built was at appropriate capacity to deal with those unicorn events, and yet also designed to minimize costs when it wasn't going through those events. So to be able to scale down and to spread its load evenly over the available computing resources. And finally, one of the funny things about the legacy that we were coming from, as you can imagine, an organization that does one thing, like deal with storm events, is pretty good at thinking about storm events, and they tend to build it into their platforms. So when we started talking about platforms that were multi-hazard, all agencies, we really had to start looking very hard at how you decouple the event data from the delivery platform. And that led to a lot of work with community research into presentation and symbology and how to get the information delivered to the public in a way that made sense but wasn't overwhelming when they started to see this much broader picture emerging. So what we came up with is, I guess, pretty much what you would expect in 2013. We took an N-tier containerized application, and the vendor we were working with delivered us an N-tier containerized application in the cloud. Okay. However, taking advantage of auto-scaling groups, taking advantage of a CDN, the cloud front at the front of it. taking advantage of the elastic compute available within AWS in the Sydney region at that time, it gave us the ability to start to be serious about responding to those peak demand events without having a whole lot of latent capacity when we weren't going through those demand events. However, if you look at that picture, there's a lot to it. Even though we've simplified it and everything's sort of nicely ASG'd, there's a lot of EC2s in there. There's databases on servers. There's all sorts of things that you look at today and you think, well, why weren't they doing it this way? Well, we were asking the same question at the time. This was early in cloud adoption in Australia, I suppose, and the simplistic adoption meant that you got elastic compute and you started putting your traditional services on that elastic compute. And that was great. But it really started to fall down when we were looking at very high volume problems like the elastic mobile. So for the mobile application, with its demands for peak message delivery, we were able to achieve that, but we had to do it by making extensive use of scaling of EC2 instances to do very simple tasks, really. And this falls into the undifferentiated heavy lifting that AWS like to talk about. When we have a cluster of worker nodes running a very simple process, which basically query database for each record, send notification, you start to really wonder what's going on here. There's a lot of infrastructure to manage, a lot of infrastructure to keep synchronized, and it's pretty fragile, right? So in the case of the elastic mobile backend, it was not a traditional end tier, and there are some of the more modern concepts in play, like SQS and SNS, but fundamentally, it's still EC2 boxes with installed software which need to be cared for and maintained. And so while it was delivering what we needed at that time, building on this platform with the fragility of it and the complexity of it meant that it was going to be very difficult. So we were stable, we were happy, and what we had at this point was a platform that, if you think back to that roadmap, the website had gone most of the way towards becoming all hazards and all latencies. The mobile app had gone just that first step to being still fire specific, but at least elastic. And now it was time to start thinking about what a converged platform would look like. And so this is where we started to look at an evolution of the website that could form the basis of a converged platform for both web and mobile. And so what we were looking for here was to start to take out these servers. Why do we have the EC2s running web servers? We've got CloudFront for that. Why do we have storage? We've got S3 for that. Why do we have a database? There's no actual database content here. Why do we have a database with a processing engine on EC2 that can fall over and stop the feed of incident data and warnings into the website? How about if we abstract all of that out into the actual logic and run it serverless? And what do you get if you do that? Well, starting with maintenance cost through the floor, right? You don't have servers anymore, so you don't have to worry about the patching cycle, and software release becomes much, much simpler. You've got so many less moving parts that the platform itself can be contained and described very simply and then built upon for future applications. So it was pretty simple stuff, really, but by moving to a single-page web app with serverless data integration platform, we were able to eliminate vast components of the platform and end up with something which was very straightforward. And so that's what we ended up with. Once we started to put this into play, we had something which was radically simpler than the website design we had previously. CloudFront, fine. Cloud Search, which is a kind of a legacy AWS product, but that provided the searching component that we required. S3 did all of the storage, and we just had a bit of Lambda off to the side to do the data integration. It's almost embarrassing to put that up. It's so simple. Okay. But where have the 12, 15, 18 EC2 nodes gone? They're just not there anymore. Right. We've still got a little bit off the side for content management system, but your base platform, radically simplified. Okay. And again, people looking at this, well, of course it's simple. right? You're not doing anything special. You just got some content in an S3 bucket behind a CloudFront. Yes, absolutely. But you tell that to somebody in 1997 or 2007, and they'll think you're crazy. So that was great. You know, we ended up with a platform that that clearly was adequate to serve the immediate need, but also well designed to keep our costs low when we were doing so. We didn't even have to worry about scaling here. There's no scaling up, scaling down. In that architecture, there's no moving parts, right? So all of our maintenance basically went away. What do we need to do? Well, you just need to you do a code release, it's new content into the S3 bucket and everything else is fine. New data integration, replace the Lambda, everything's fine. Very, very simple. And yeah, obviously very happy to make it so simple. When we started to look at that platform as the converged platform for the mobile backend, that's when we started to talk about adding some of that complexity back into play. So for our mobile backend, what we needed was not just the display of incident data and warnings on the website, but we needed personalization and tailoring of that information. We needed what we call a watch zone, which is a geospatial area or multiple geospatial areas of interest that will filter the events which are delivered to that user. Obviously, we needed to maintain a user database and a device database to keep track of who we're sending what data to. Obviously, auditing becomes much more important in this scenario, as you need to keep track of who received what when. So there's a lot more to it from a functional point of view, and that would drive the complexity of the architecture. But we challenged ourselves. We asked, is it possible to maintain essentially a low moving part solution, or at least a low server count solution, without compromising on those architectural principles? And so that's what we tried to do. We designed for a unified serverless backend, where we took the first testing of the waters with a Lambda-based data integration component and scaled that out to the full API backend for the application. We removed our dependency on third parties, so we didn't want to use third-party notification delivery services. We wanted to do that all inside AWS. We wanted to make sure that what we delivered was more available even than what we had previously designed. And that's when we started to think about multi-region, multi-AZ, active-active architecture, right? And whether it's possible to run a reasonably complex backend in two different regions, right? And so that's what we set out to do, and we achieved that through some reasonably clever replication, but not too much else going on. And we did it without introducing any significant number of EC2 instances or any real complexity to the backend. Sorry, complexity to the backend, yes, no management or maintenance overhead to the backend. So now you can see that initial core of CloudFront, S3 bucket, Lambda integration, that's shrunk down to that component, basically in the top row, middle. And we've started to build around it, built an API, built a data storage backend, and put in a lot of serverless, a lot of Lambda, to do the glue logic for what we talked about as being the undifferentiated heavy lifting of the original mobile backend. So when we're doing those database queries and turning them into push notifications, that's Lambda, right? When we're managing the response to, hey, user just created a new watch zone and they want to store it against their user, that's Lambda, right? The database, well, that's serverless, well, that's RDS in this case, but not something you have to manage. When the user authenticates, Lambda. When the user, when their device turns on and notifies us that it wants to receive notifications, Lambda. So in terms of the backend, Lambda, API gateway, extending what was already there in terms of CloudFront and S3. Very straightforward. Now, unfortunately, this picture does hide some of the complexity of the true complexity of the solution. So while it's straightforward to do that, when we're talking about, say, 2 million push notifications per minute, 60-odd million an hour sustained, we're talking about a fairly high level of compute going on in the back end, and very high assurance levels that need to be applied to every one of those notifications. So it's not good enough to have a 95 percentile or 99 percentile success rate. It needs to be 100, right? So heavy use under the hood of SQS, assured delivery, DLQs, very heavy utilization of sharding in the database to spread the load. And I mentioned active-active multi-region, very heavy use of parallel multi-region operations to maintain and to deliver the sustained throughput, actually the peak throughput for the push notifications. Some of that was due to AWS limitations, like the number of SNS to mobile push notifications per minute it could sustain, and some of it was just due to, hey, we've got a big complex application. But by and large, we managed to achieve a unified serverless and mobile backend with full API without making the architecture overly complex, and yet still improving on both the cost of operation but also the resiliency and the availability of that platform through multi-region active-active. So really, up to that point, we have gone through, perhaps we've taken this application or this system, this product through a journey that should look pretty familiar to most of us. Maybe not all of us have serverless applications, maybe not all of us have major applications, business critical applications in the cloud, but there's nothing terribly mind-blowing about taking a website and putting it in the cloud, right? There's not much more to it than putting an API in the cloud, putting a bit of compute backend in the cloud. It's all fairly simple steps. Now, we did it with mission critical, public safety critical applications, so it's pretty big stuff for us. We were very cautious about how we approached it. We put a lot of work into our own skills and our own team to do so in a way that we could sustain the development and the operation of this platform. But by and large, it's a journey that should look fairly familiar. Where we are now is we're talking about what the future holds as we move ahead. What have we learned from what we've delivered today? So some of the things that we've learned is that, for example, AWS services, as they are introduced and mature, can radically change your architectural thinking. When we started with EC2s, with containers. Once you start layering on RDS, layering on Cognito, layering on API Gateway, huge chunks of your architecture can be refactored out of the solution, right? Looking to the future, it's always useful to watch for the most painful parts of the application architecture that you have at the moment and keep an eye out for services that will change or to eliminate or simplify parts of the application architecture in the future. Now, secondly, obviously with government, we don't throw money away. Sorry. We try not to, but in all seriousness, we don't have an unlimited supply of money to go through, to spend a lot of money for a small benefit, right? We've got to share it around. We don't get everything we need whenever we need it. We haven't gone through this journey in Emergency Management Victoria by saying, hey, I feel like making a new version. Can I have another $10 million, please, or whatever, That's not the number. What we always do, is we look for an opportunity where a pain point can be married to a feature, right? And we start to look at what the next generation that delivers those significant benefits to the public would mean to how we change the application architecture that we use to deliver that solution. And sometimes that's a bit painful too, because you're sitting there on a legacy application now, legacy is a whole year old or 2 years old or whatever, but as you see new technologies and new approaches coming out, it's pretty painful to look at it and say, well, gee, if we spent 3 months and 5 developers, we could have the next generation that does, exactly the same thing, but better, right? And of course, that's always painful, particularly with the pace of change that we see within AWS, within cloud space entirely. There's always new things coming out. There's always new opportunities to adopt those and improve your architecture, but obviously you have to match it to the need and to the compelling reason to do an upgrade. The next thing which we've learned is that with a platform like this, just going serverless is a really good start, but you tend to end up with a proliferation of functions in the cloud. And that can be manageable, and in fact, it's probably no worse than a traditional architecture with say, a proliferation of Java beans in the container. But it's still pretty ugly, right? And so what we're starting to talk about now is paring back or taking our Lambda utilization and starting to think about where we actually are using Lambda now for undifferentiated heavy lifting, and see whether we can just do service-to-service integrations. So one of the patterns you see over and over again now with serverless is your functions of code or your microservices talking to microservices, talking to service, talking to microservice, talking to service, and a lot of coordination and service to service means a lot of code in the cloud that needs to be maintained and evolved. So we're looking to eliminate those code-to-code points and code-to-service points and start doing service-to-service integrations. One of the areas where we see that works really well is at the API gateway level. An API gateway can do an awful lot of doing controlled access to other AWS services without having code in the way. So we started to look at, for example, this model. If we were to do it again, would we still have databases as a big part of the back end? Would we still have Lambdas responding to every API call? And the answer to those are both no. Right? It'd be much nicer, for example, if the API calls from the clients went straight into the data store, whether that's Dynamo or S3 or whatever it might be. If the replication between different regions wasn't via queues and Lambdas, but was S3 to S3 or Dynamo to Dynamo, there's an awful lot you can do today to utilize service-to-service integrations in AWS to compose an architecture rather than building glue between services. And so that's where we're taking that compositional architecture in the future. The main benefit, of course, two main benefits. The first one is that if you don't have your code in the way, you can be a bit more resilient in terms of the operation. It's one less thing that can go wrong. It's possible for Lambda to fail. It's possible for Lambda to have a threshold limit. If there's no Lambda in the way, then you're not going to have that problem. But it also reduces one of the biggest costs ongoing, which is a cost that limits both the amount of new features that can be added, but also the complexity of the system, and that is how much code is running to keep that system in operation. So more service-to-service integration means less code to maintain, less code to write, more flexibility overall. And we can do that by the usual refactoring approaches of simplifying, consolidating, and configuring application or code modules. So the last thing which I'd call out is that our journey has been successful largely because AWS has delivered the absolute building blocks that would never have, without which we could never have started this journey. And thinking back to elastic computing, that is the enabler, right? Multi-AZ, elastic computing, load balancers in the cloud, CDNs in the cloud. Without that stuff, we couldn't have taken that first step, let alone the second, third, fourth steps as we've taken those applications into more and more mature architectures. So really, you need to be aware of the enablers that made the application possible in the first place when you're looking for those evolutions of that application. So that's pretty much all I wanted to share. But if you think about, just to wrap up, that composed architecture approach, this is something which we've been playing with at the moment. That's forming the basis of our next generation interagency data interchange and data lake platform. And we're taking this as a platform which can handle any number of different data integrators into a data lake, into an ODS, with a very, very small footprint of code. And so we've got a total of 5 Lambdas providing every data integration that we want today, backed by very reliable AWS services that in many cases, particularly the critical parts, are going straight through to service, or are using Lambda to provide orchestration or configuration of those service-to-service interconnections. And so some of the architecture is actually dynamic, based on dynamic compositions, based on the configuration that we feed in. So anyway, it's sort of where we see the future, but it's maybe something I'll talk about next year. So thank you very much for your time. I've really appreciated presenting to you. I hope there was something in there for everybody. The only takeaway I want to make is that I'm very pleased to have been here and very thankful for AWS for giving me the tools to make Victoria at least a little bit safer. Thank you.
Thanks very much, Michael. I just wanted to share a couple more things with you and also a plug for a later session today. So one of my frustrations, both as a solutions architect and also as a citizen, is that a lot of work gets repeated around Australia in different states. And so Victoria have spent years and a lot of effort building, what is a world-leading system for solving some of these problems. In my dreams, other states would use the same systems, or the states would collaborate. And a lot of people call me a dreamer on that front, but I'm still hopeful. But the plug I wanted to make was actually for the last session that's in this room today. So the title of the session is just Building a Cross-Agency Shared Service. But so it's also a customer presentation. The presenter in that talk is Greg Van Gants, who's from South Australia. So he's from the Department of Planning, Transport and Infrastructure in South Australia. He runs the geospatial practice there, but over the last 2 years, he's both moved a whole lot of workloads to AWS, but now has 18 different government agencies using that same infrastructure. And his journey is partly serverless, but actually is more traditional on-prem infrastructure. But he's going to talk about how they did that, the things that they learned, as well as just some of the tools they use. But so I highly recommend that one. So it's just called Building a Cross-Agency Shared Service. It's the last session that's in that room today. If you did want to come up and talk to either Michael or myself about anything that's been in this presentation, we'd be more than happy to talk to you. And wish you a good day. Thanks very much.